Hello class, today we're going to be learning lesson 5-6 in your algebra books. This is about being able to solve absolute value inequalities. So the previous lesson was about solving absolute value equations. So I want you to remember or recall that if you have absolute value equal to 3, what this means is that the distance from any number x back to 0 equals 3. So I think the key word is distance, okay? Going back to 0. So if you remember, when we solved the absolute value of x equal to 3, we found two solutions on our number line. We found that it could be right here at 3 because the distance from this number 3 back to 0 is exactly 3, but also we said that it could be -3 on a number line because the distance, if I was going to measure from -3 back to 0, is also 3. So that's really important for you to remember when we're solving absolute value inequalities. So let's take a look at two inequalities here, very basic. The first one says the absolute value of x is less than 3. So putting this in terms that we just used, what we're talking about is that the distance from some number, x, back to 0 must be less than 3. So I'm going to put a few numbers on my number line. Now, can it be equal to 3? No, it cannot. Okay, but could it be 2? Is the distance from the number 2, if I put that on my number line, back to 0, is that less than 3? Yes, it is. 2.5 is less than 3. 1 is less than 3. So I'm already thinking that I'm going to be shading all of these numbers in here as possibilities of values of x so that the distance from that number back to 0 is less than 3. But also, if I had -2 over here, is that distance back to 0 also less than 3? Yes, it is, but not -3. So I'm actually going to be shading all of these numbers in between -3 and +3 on my number line, okay? Because all of those numbers in there will give me a distance back to 0 that is less than 3. So really I'm forming this compound inequality that we've practiced before. -3 is less than x, which is less than +3. So if you see an absolute value inequality and it has a less than, or if it has a less than or equal to inequality, either one of those, I want you to think of the word and, okay? So I'm going to put this nice and big in a pink box just to help you out, to organize your thoughts. Now let's think over here. If I have the absolute value of x is bigger than 3, is greater than 3, then that means the numbers that I'm going to choose for the distance to be bigger going back to 0 has to be bigger than 3. So I could choose the number 4, for instance. The distance from 4 all the way back to 0 is definitely bigger or greater than 3. And same with 5 and 6 and so on. And also if I chose some negative numbers, like -4, is -4 the distance from there going back to 0, if I measured it, is that greater than 3? Yes, it is. But it cannot be -3. Cannot be +3. It cannot be -2. The distance from -2 back to 0 would be smaller than 3. So really what I'm looking at is I'm looking at these values that are kind of on the outside, that are going and getting bigger in the positive direction, or they're getting even smaller in the negative direction. So again, I don't know if you can notice this, but kind of what it looks like is that when I have a greater than symbol, it's forming it into another compound inequality, but this time it has the word or. So for instance, it might have all of the x values that are less than -3. That's what I have right here. And it also has all of the x values that are greater than +3. So any of those values, that's why I have an or there, are going to satisfy this absolute value inequality. So I think it's important for us to realize that if we have a greater than or equal to or a greater than symbol, it's going to clue us in that it's going to be an or compound inequality. Okay? So let's do another quick example. I want you to solve the absolute value of x that is less than 8. So again, I'm seeing that less than symbol. So what I'm going to be thinking of is the and. Okay, it's going to be a compound inequality. So I already know that this is going to be -8 is less than or equal to x, which is less than or equal to +8. And if I was going to chart this on my nifty number line, the values that I'm going to shade are going to be between -8 and +8, because it's all of those in between. And I'm filling in the bubble because it can be equal to as well. Now, to solve this next problem, I have the absolute value of v is greater than 2/3. And when I see this greater than symbol, I'm going to be thinking of or, which means I'm going to have a split compound inequality. So I'm going to write this out as v is greater than 2/3, but also it's going to be v is less than -2/3. This is very important. The first one looks identical to up above, v being greater than 2/3, but when I write the second part of the compound inequality, it flips the inequality and gives us the negative version of the number. Okay? So if I'm going to graph this, it is going to be just two inequalities. And I'm going to have 0 right here, and I'm going to have -2/3, and I'm going to have +2/3. And this is telling me all of those numbers that are less than -2/3. So I'm going to be shading this outside, continuing on in the negative direction. And I'm also going to be putting my marker right there on +2/3. It's an open circle, and it's going continuing in the positive direction. Okay? So as you can see, when it's less than, it's going to be an and it's going to be everything in between. But when it might be greater than or equal to, it's going to clue you into the or compound inequality. So why don't we look at some more difficult ones. So just like we did earlier when we were solving equations with absolute value, we're going to do the same thing. But now I'm going to split this up into my two different inequalities. And I'm looking and I see that I have a greater than or equal to symbol, which is going to clue me in that it's going to be an or compound inequality. So it's going to be x minus 5 is greater than or equal to 7. The second one is also going to be x minus 5, but again I'm going to flip the inequality, so it's less than or equal to, and I'm also going to write the negative version of the positive 7. And now I can solve both of these. I'm going to add 5 to both sides on my first one. And I'm left with x is greater than or equal to the number 12. And for the second one, I'm going to add 5 again. And I'm left with x is less than or equal to -2. So when I graph this on my number line, I'm going to be graphing all of those solutions that satisfies this absolute value inequality. So -2 here. 2, 4, 6, 8, 10, and 12. Got to squeeze that in there. So all the numbers that are greater than or equal to 12, so it's going to be going off in the positive direction. I'm going to shade all of those values, or all of the possible values that are less than or equal to -2. So I'm going to shade going in that direction as well. All right. For this next one, I have the absolute value of 2w minus 1 is less than 11. And I see this less than symbol, so that's going to clue me in that it's going to be an and compound inequality. So I can solve it as two different inequalities and then putting them back together, or I can write it as the opposite to begin with is going to be less than 2w minus 1, which is less than 11. Okay? And now I want to add positive 1 to all three parts to get that w by itself. Negative 11 plus 1 is negative 10, which is less than 2w, and that is less than positive 12. Final step to get w by itself is to divide everything by 2. By doing so, I get negative 5 is less than w, which is less than 6. Okay, now when I graph this on my number line, 0, 4, 6, and 2, 4, 6. Oops. All right, it is all those numbers in between negative 5 and also positive 6. So it's going to be an open circle, and I'm going to shade everything in between. All right, so we're all set on that one. We're going to do one more problem now. And this is solving the inequality where there's more things than just the absolute value on the left-hand side. So like we did with equations, we need to first isolate what is inside of the absolute value bars first. So what we're going to do is we're going to subtract the lonely number. We're going to get rid of that. So that's subtracting 3 on both sides. And when I rewrite this, I have negative 4x minus 5 inside of the absolute value brackets. 9 minus 3 is 6. So now, because I see that it is less than, that's telling me that it's going to be an and. Okay. What we did last time was we combined both of the inequalities into a compound inequality, but this time I'm going to separate it just to show you that you can do it both ways. So the first one will be negative 4x minus 5 is less than 6. The second one that I'm going to write is negative 4x minus 5 is greater than, I'm going to flip the inequality, and I'm going to give it the negative version of what I had before. So instead I had 6, now I'm going to have negative 6. I'm going to solve both of them just like you would an equation. First you're going to add 5 to both sides, and you're going to be left with negative 4x is less than 11. One more step, you're going to be dividing both sides by negative 4, and when you divide an inequality or multiply an inequality by a negative number, it's going to flip the inequality. So instead of being less than, now it's greater than negative 11 fourths. Or that's the same as negative 2.75. Okay, so you can leave it whichever way you'd like. I'm going to solve my other one now that I have on the right side. Again, I'm going to add 5 to both sides to get that variable by itself. Cancels out the 5's there. I'm left with negative 4x is greater than negative 1. Just like I did before, to get the x by itself, I'm going to divide both sides by negative 4. Those cancel out. I'm left with x is, because I'm dividing by a negative, flip the inequality, so less than positive 1/4, or 0.25. Okay, so I have my two inequalities. If you wanted to combine them, you could combine them. So it would look like negative 2.75 is less than x, which is less than 0.25. Okay, putting it on a number line. I'm going to go by 0.5s. So I have my 0, and I'm going to have a half right here. I'm also going to have negative and half, negative 1, negative 1.5, negative 2, negative 2.5, and I'm going to squeeze in my negative 2.75 right next to it. So I have my first one right here. Okay, it's an open circle because it's less than. And I also have my second one right here at negative 2.75, and it's going to be everything in between. Okay, all those in between. So I'm going to shade that. And I'm done. So what I'd like you guys to do before you come back to class on your own is I'd like you to solve this inequality, the absolute value of 2x plus 3, minus 4, which is less than or equal to 5. So first solve it, and then I'd like you to graph it, and we'll check your solution and your graph when you come back to class.